We had a math department meeting yesterday, and in the meeting, Ms. Shavek said, "So you teach your compound interest different?" And I looked at her and was like, "What are you talking about?" And she says she was working with somebody, and that this was the formula that we use. Is that true? What do you think? It is actually true. Under what conditions do we use that formula instead of this formula? What's the difference between the two? What's missing? N. N is missing, right? Well, it's not really missing. This formula is used when the N is equal to 1. What does the N stand for? Number of compounds per year. Where is it? Right? The number N stands for the number of times that the interest is compounded every year. So if we have something that is compounding annually, then that means it would compound one time a year. So the N would be a 1. And in that case, this would be the formula that we would use, right? But it's the same as that formula. It is this formula. It's just that the N is 1, okay? Excuse me. Does that make sense? Okay. So that's our compound interest formula. What does the A stand for? What's the A stand for? Amount. Amount of what? Amount of money we have at what point? After we're finished all of the compoundings, right? So P, what does that stand for? The principal, which is the initial deposit or the initial investment or the initial amount of a loan. It could be a loan, right? How about the R? The interest rate. And remember, it has to be in decimal form. So whatever the interest rate is, we divide by 100. Okay. And then N is the number of times that we compound it per year. So if I'm getting quarterly compounds, it's 4 times. And a monthly compound is 12 times. Okay. And then, of course, T is the time or the number of years. Okay. Okay. So I did give you this worksheet, right? And you did like the first page of it. Okay. Did you have questions on that? I feel like you all did. I feel like you did well on your quiz, right? Let's see. Oh, I don't have the quiz in here. What more? Did we have a quiz? Did I grade the quiz? It's in RenWeb? Okay, it's just not in my book. Okay. Okay, so let's move down. So we've talked about simple interest, right? I equals PRT, right? That's simple interest. So just as a reminder, right? Simple interest, I equals PRT. Tell me how that's different than compound interest. Say again? Okay. So if I invest my $100, right, and I get 5% interest, then that means I make $5, right? So that means now after the first year, I have $105. What happens in the second year? I get 5% interest. It's of the original amount. So compound interest, I'm getting interest on my new balance also, right? Okay. So if I wanted to figure out how much money I had, right, I would take the original amount, that principal, and I would add the interest to it. So this formula will often look different, right? So with simple interest, right, that's the interest, PRT. So sometimes the formula will look like that. The amount of money I have is the principal plus the interest I've earned, right? But sometimes the formula will look like this, where basically we're just factoring that P out. Okay. So if I have a simple interest loan for 10 years and I'm making $5 a year, I know I'm going to have $50, right? Well, I could figure out, okay, how much money do I have? Well, I have $100 times 1 plus 0.05 times 10 years, right? So that's going to be 100 times 1 plus 0.5. So that's 100 times 1.5, which is $150. That's how the formula works. Now we did that in our head because it's an easy number. $100, I'm making $5 a year. 10 years, that's $50, right? How does that compare to our compound interest formula? A equals P times 1 plus R over N to the NT. Excuse me. The formula looks very similar, doesn't it? Right? So how does it compare to the compound interest? I've got $100, 5%, and we're going to say we're compounding it annually. So that's $100 times 1 plus 0.05 divided by 1, because it's annual, to the 1 times 10. So it's a little bit different. So instead of multiplying by 10, we're raising to the power of 10. Okay, so 1.05 to the power of 10. And then we're going to multiply that by 100 because that's how much we invested.
Attention all students and teachers, please disregard those bells. Thank you.
So this is going to be $162.89. So compound interest is going to give me more than simple interest. Okay. We okay with that? Okay. So we're going to move on, and I'm going to introduce the number E to you. Excuse me. Okay, so let's see. Jackie, I want you to take this formula in your calculator, okay? So this formula looks very similar to our compound interest formula, which looks like this. Okay. So what we're going to do, a lot of times we'll do this in math and we'll try and understand the behavior of a function when there's multiple variables like this. We're going to say, okay, let's pretend that we invest $1 and that we get 100% interest for 1 year. Okay. So that's where this formula came from. Okay. The rate R is 1, T is 1, and P is 1. So P and a T here. Okay. So that's where that formula comes from. So we're just kind of exploring that. So Oh my goodness gracious. So Jackie, I'm going to have you calculate this for n equals 1. Ariel, I'll have you do it for n equals 2. So if we were compounding semi-annually instead of annually. Okay. Annalie, we're going to do quarterly, which means this would be, n would be 4. Caitlin, I'll have you do it for monthly, so n is 12. Excuse me. Let's come over here. Allie, I'm going to have you do it weekly, so n will be 52. Ava, we're going to do it daily, so n will be 365. Jess, we're going to do hourly, so n is 8,760. Now, how about every minute? So I would take the hourly and we're going to multiply it by 60 because there are 60 minutes in an hour. Okay. So let me see here. Gavin, will you do that one? Compound it every minute. Okay. And then Alex, would you do every second? Okay. Okay. Okay, Jackie, what did you get for annually? 2. Okay, who has semi-annual? All right, what you get? 2.25. Okay. Quarterly? 2.44. Okay, don't round it. Is that rounded? It came out to 2.44 even?
Oh, wait, 2.441.
That's kind of surprising to me, so let me just double check that. 1 plus 1 divided by 4 to the power of, to the power of 4. Okay, 2.44140625. Do you have your calculator rounding?
Oh, I do have that.
Oh, well,
Oh, I had to say the whole thing?
yeah, that's why I said don't round. Okay, how about monthly? Who's got that?
2.613035295.
Okay.
2.69259695.
Daily? Who has daily? Okay. Is it a graphing calculator or? Okay. Not sure why your calculator's saying error. We'll have to look at that for you. 2.714567482. See what's going on. Okay. Hourly.
2.7118126691.
Okay. Every minute.
2.7182792526.
And then every second.
2.71828247.
Okay. Okay. So what you should notice, right? As we increase, the number is getting closer and closer and closer to the previous one, right? So we went from 2 to 2.5 and then 2.5 to 2.4, right? When I got down here, I was able to start writing the first few digits before you even started talking, okay? Because the numbers were getting closer and closer and closer. If we were to plot these numbers, right? If we were to plot this on a chart, see if I can find a space here. I'll just do it here, right? Where the x-axis was n and the y-axis was the 1 plus 1 over n to the power of n, right? This curve would look something like this. Oops, didn't mean to do that. That's wrong. Sorry. The curve would look something like this. Okay? And it is approaching this number that we call E. And E is approximately 2.71828. E is a number just like pi. It just keeps going and going and going. Okay? E is always the same number. E is a number that was actually calculated by a man named Leonhard Euler. Leonhard Euler. Some people pronounce it Euler. Okay. Leonhard Euler. He's the one that calculated the value of E. And basically, by studying this type of exponential function, okay, and what we observed, or what he observed, was that as that n got infinitely large, right, here's 2.718, here's E right here, as that n got infinitely large, the value of that exponential function would just get closer and closer and closer to that number, but it never crossed that line. We have that horizontal asymptote. It never went past that line. Okay? That line is what we're calling E, 2.718. So I could go 5 billion, and this 1 plus 1 over n to the power of n will not cross 2.71828, blah, 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 blah. Typically, when we memorize this number, just like with pi, we usually just do 3.14. If we want to be more precise, 3.14159. Euler's number, 2.71828, is usually where we go with that. However, just like pi on your calculator, there is an E. So there are two places to access E on your calculator. If you just want E, use the second function and it's above the division sign. Okay? And there's E. If I need E to a power, I use second function and it's above the ln, which is just to the left of your 4. Does everybody see that on their calculator? Okay, so if I want E squared, okay, E is a constant. E's a number. Anything I can do to a number, I can do to E. I can add E. I can multiply by E. I can divide by E. I can raise it to a power. Okay? Anything you can do to a number, you can do with E. Okay, so I mean, I could actually have I could have x plus e. That's a number, right? That's a binomial. That's just like having x plus 3, right? So anything you can do to a number, you can do to e, and it kind of feels wrong. To be honest, it feels wrong. You see that e, and you like, oh, I can't add them together. I can't add that. I can do 3 plus e. 3 plus e is going to give me a number. It's going to give me approximately 5.71828, right? E is approximately 2.71828. So if I add 3 to it, I get 5.71828. But when we see 3 plus e, what's our instinct? We can't add 3 plus x. So we see 3 plus e and we're like, oh no, can't do it. But you can, because e is a number. Okay? Excuse me. Okay, so E, one of the most common applications of E is using compound interest and something that we call continuous compound interest. So I can compound monthly, which means it's 12 times a year, weekly, 52 times a year, daily, 365 times a year. I could compound every hour, right? So 8,760 times a year. We could compound every second, but we can also compound continuously. Now, compounding continuously introduces a whole new problem, because the moment I start to compound, that moment's over, right? So compounding continuous introduces this whole new issue. So we actually have Leonard Euler came up with this way of doing that, and that's by using this formula here. It's similar to our other compound interest formula. Okay, I call this the PERT formula. A equals P times E to the power of RT. Okay, so now we have 3 different formulas that we've used for, I'm going to just say 2 formulas. I'm not going to include the simple interest. 2 formulas for compound interest. This one, where I have a finite number of compounds, right? N is a number that I can actually count. And then we have the PERT formula. Looks like that. Okay. So the rest of this worksheet is using the PERT formula. Okay. So let's just look at that number 1 first. Actually, no. I'm going to have you guys, I got to figure out a way of catching up. Let's stop with this worksheet. I'm going to give you another worksheet, okay? And I'm going to have you guys work with this one. And that way that'll save us a little time. Okay, you'll notice on the worksheet that I just gave you, let's see if I can pull it up here. Yeah. I've got the formulas right there for you to refer to, okay? I'm going to have you turn to the second page right now. And you are going to skip number 2C. You're going to skip number 3 and number 4. Okay? Okay, you can work with a partner? Yes, sir. No, sir. First 5 minutes of class only.